Hi, Object Coder. We're going to go from whiteboard scratch paper now to code. So some might call this the fun part. I actually like the whiteboard scratch paper myself, but this is fun too. If we look back at the whiteboard or scratch paper, we see we need a function, right, that gives us a value, very simply a value that's less than 0, and that'll tell us to go left or go right. And we're going to feed that function the data or the key, depending on the type of insert or search. So let's take a look at the code. If we review, I'm going to go through this quickly because it's all here for you and you'll learn a lot more by playing around with it. Here's the basics of the functions though, how they work. I think you're used to that, or if not, play around with that. And that's how a function looks. These are the inputs and these are the outputs. And these are, of course, Java always requires a declaration. So we have a declaration there. And of course, I would always pull up the APIs to, on the web to get familiar with those. We really only need two names though. We need compare. We send compare to the comparator and we send apply to the by function. So let's take a look now. So we have we're going to have two examples here. Actually, I'm going to look at one at a time. I think it's easier. Let's look at a sort function that compares by ID. All right, we have two employees here. We're going to look by ID. So we're adding, let's say we're inserting Asha into the tree. So we would assume then, Asha and ID 10, because this is a sort by ID, the 10 should be greater, right? So we would expect this not to be 0, this first output here. So let's give that a run. And we have to activate the correct one here. And there we go. And we're just going to look at the first output. First output is 1. Yeah, so it gave us a value greater than 1. We know that this record, this object, should go to the right. Now let's look at if we did we had a sort function here. And remember, these are provided for us. We don't really care what's inside the sort functions. It's general, right? When we're inside that node coding, we just have the sort function in hand. And this is what the result is what's going to drive us, right? If it's less than 0, we're going to go to the left. And I think this one should be. This one is actually sort by name, or sorting employee 2 is the first argument here. So we'd expect that to be less than 0, right? Because Asha is less than Sally. So let's give that a run. This is a second output here. Second output is less than 0. We don't care about the actual value, just less than 0. And that would drive us to the left, right? That would drive our insert, our add to the left. So that's really all we need right here. That's our big. And of course we're in a node, so we'd have to go node, dot get data or what have you, for that one there. All right, now let's take a look at the other one. The other one is where we search for a key, and let's see if we can pull that up quickly. So we have a key here instead, right? Because we're searching for a key. That's how we want our guests, our object users, to use our tree to be able to search for a key. That would be cool. So again, we have a function here in hand that's provided for us when we're coding. We look at the result here, and then that'll drive our search, left or right, or possibly a match. So what do we have here? We have actually a 10, and we're comparing it to this node here. So we'd expect that to be non-negative, right? This is the first output. So let's get this activated and deactivated. All right, we'd expect that to be greater than, okay, that is greater than 0, non-negative, I should say, 1. So we would go to the right. That would tell us to drive our search to the right. Okay, let's look at this one here. This is by name. So we're comparing employee here is Sally, and we're searching for Asha. So that should be less than 0, the second output, right? Should be less than 0 and drive our search left. It's less than 0, so it drives our search left. So this is the magic right here that we need in our node logic, right? It would just have an if statement. If that is less than 0, we would go left. Now, what if we actually have a match? And if we have a match, we return the result, right, on a search. So let's actually search. The node here is actually Sally. So we're pretending we're inside of the node Sally. Let's search now for Sally. We would expect the second result now to be 0, which would tell us we have a match. It is 0, so in that case, we have a match. So that's really what these functions are about. This is the key line here, one line of code that would drive it. And then for the insert, similarly, one line of code would drive us. So that's a quickie there, and you'll get more by playing around with it, of course. So we'll talk to you soon.